This section introduces the core challenge. We're using Sklearn's dictlearning function for dictionary learning. But the reconstruction error is too high. I need to identify which strategies could potentially reduce this error. It's like trying to rebuild a puzzle with some pieces missing. I want to find ways to improve how well the reconstructed image matches the original. This option suggests increasing the number of times the algorithm attempts to find the best solution. Think of it like giving the puzzle solver more time to work. More attempts could lead to a better fit, but it takes longer. Here, the idea is to reduce the constraint on how simple the solution needs to be. A lower ALPHA means we allow for more complexity, potentially capturing more of the original data's details and thus lowering the error. It's like giving myself more pieces to work with. This is the opposite of B. I'm enforcing a simpler solution, potentially losing important details in the process. It's like trying to rebuild the puzzle with fewer pieces. The result will likely be less accurate. This suggests trying a different algorithm altogether. Different algorithms have different strengths and weaknesses, and one might be better suited for this specific data. It's like switching tools. One tool might be better for a specific task. To solve this problem effectively, I need a thorough understanding of how the parameters ALPHA and MAXITER affect the dictionary learning process, and I need to understand the different solvers available. This highlights the crucial knowledge required. I must grasp the roles of ALPHA, controlling sparsity, MAXITER, controlling the number of iterations, and the various solvers, as each impacts the model's outcome. I see a high reconstruction error in Sklearn's dictionary learning. That means the dictionary isn't representing the data well. Let's fix it. One thing I can try is increasing the number of iterations. More iterations mean more chances to find a better fit. Think of it like repeatedly refining a sculpture. The more you work on it, the closer you get to your vision. The parameter alpha controls how sparse the representation is. A smaller alpha means a less sparse representation, capturing more details, and potentially lowering the error. Think of it like using more paint colors to paint a picture instead of using limited colors. Using more colors will allow to show more details of the picture. Different solvers in Sklearn's dictionary learning work in different ways. Switching solvers might give you a better solution. It's like trying different tools when building something. Some tools are better suited for certain tasks. Based on the analysis, I've found 3 potential solutions to reduce reconstruction error: increasing the number of iterations, decreasing the sparsity parameter, and trying a different solver. These approaches increase the chances to find a better solution. I'm tackling a problem where SCIKITLEARN_SDICT_learning function isn't working as well as it should. The model is struggling to accurately reconstruct the data, resulting in a high reconstruction error. This means the dictionary the model learns doesn't represent the data very well. We need to find ways to improve this. We're using a specific function within the SCIKITLEARN library called DICT_learning. This function is designed to find a good dictionary of features that can represent the data efficiently. It's like finding a set of building blocks that can be used to recreate any image in the dataset. The challenge is that the current building blocks aren't very good at reconstructing the original images. My model has a high reconstruction error. This means the data it tries to reconstruct looks quite different from the original data. Imagine trying to rebuild a Lego castle but using the wrong pieces. It simply won't look right. I'm exploring ways to improve the model's accuracy, essentially making the reconstructed data look much closer to the original. Several approaches are being considered to reduce this error. I can try giving the algorithm more time to find a better solution by increasing the number of iterations. It's like giving the Lego builder more time to work. More time may lead to a more accurate reconstruction. I can try making the representation of the data less sparse. ALPHA controls how simple our building blocks are. A lower ALPHA allows for more complex building blocks, potentially leading to a more accurate reconstruction even if it is less efficient. Increasing ALPHA makes the representation too simple. This is like only using a few very basic Lego bricks. It could lead to losing important details and thus, a higher error. I can try a different algorithm to find the best building blocks. Different algorithms have strengths and weaknesses, so one might work better than another for this specific problem. It's like trying a different Lego building technique. I see this option as a good one. The _max_iter parameter sets how many times the algorithm tries to improve its solution. Increasing it gives the algorithm more chances to find a better fit, potentially reducing reconstruction error. It's like giving a puzzle solver more time to find the solution. More time, better chance of a lower error. This one's also likely to help. _alpha controls how simple the representation is. A lower _alpha means we allow a more complex, less sparse solution. Think of it like using more colors in a painting. You can capture more detail and get a more accurate picture of the original. A lower alpha is more likely to reduce error. Different solvers are like different tools for the job. Some are better suited for specific situations. Maybe the current solver isn't the best choice for this dataset. Switching could improve performance and the reconstruction error significantly. It's worth exploring. I would not suggest this. Increasing _alpha makes the representation too simple, potentially losing important information, leading to a higher reconstruction error. It's like trying to paint a portrait using only a few, very broad brush strokes. You lose the detail. So, I'd avoid this option. This is the problem. You're trying to improve how well a model reconstructs the data. In short, you want to reduce the difference between the original data and the data reconstructed by your model after dictionary learning. I see you're tackling dictionary learning using Sklearn's dictlearning function. The goal is to find a set of dictionary atoms that can efficiently represent your data. A high reconstruction error means the dictionary isn't doing a great job of reconstructing the original data. We'll explore ways to improve that. You're experiencing a high reconstruction error after using Sklearn function. This means the dictionary created from your data is not representing the original data well enough. Your goal is to improve the accuracy of this representation. Parameter ALPHA controls sparsity. Lowering ALPHA makes the representation less sparse, allowing for more detail and potentially reducing reconstruction error. Think of it like this. A higher ALPHA is like using only a few broad brush strokes to paint a picture. You lose detail. A lower ALPHA lets you use more detailed brush strokes, improving the likeness of the picture to the original. The MAXITER parameter sets the maximum number of iterations the algorithm runs. Increasing MAXITER gives the algorithm more chances to find a better solution. Think of it like giving the algorithm more time to refine its representation of the data. More time equals more optimization. Different solvers within dictlearning have different strengths and weaknesses. Some might handle your specific data better and help reach a lower reconstruction error faster. Think of them as different tools. Some might be better suited for a particular job than others. This is the overall question you're trying to answer in this quiz, focusing on methods to decrease the reconstruction error in dictionary learning. The options are related to the parameters and methods that can influence this error. This problem focuses on using Sklearn's dictlearning function. We'll explore how to reduce the reconstruction error, which basically means making the model's predictions more accurate and closer to the actual data. We'll learn about parameters that control this process. It's like fine-tuning a recipe to get the perfect taste. Imagine you're trying to represent some data using a set of building blocks, the dictionary. A high reconstruction error means we're not doing a great job of building the data back from those blocks. The reconstruction isn't very accurate. We need to find ways to improve the accuracy of our reconstruction process. Think of it like trying to rebuild a Lego castle from its pieces. A high reconstruction error means parts are missing or misplaced. This is the core question. How can we improve our model's accuracy by tweaking some parameters? We have several options, and the challenge is to select the ones that will improve our Lego castle reconstruction. I'm suggesting giving the algorithm more time to find the best solution. _max_iter controls the number of attempts the algorithm makes to improve the Lego castle. More attempts might mean a better result. Here, _alpha controls how simple, or sparse, the representation is. Decreasing _alpha allows more complexity, potentially capturing more detail. It's like having more types of Lego pieces to use. Increasing alpha makes the representation simpler. While this can be good in some cases, it might lose important details, increasing reconstruction error. It's like having too few Lego pieces for a detailed castle. Different solvers use different techniques to find the best solution. Switching solvers is like changing construction techniques to see if you can build a sturdier and more accurate castle. This section summarizes how different parameters influence the process. Understanding the role of parameters like alpha sparsity, and max iter iterations, and the choice of solver is crucial for effective dictionary learning. I see a high reconstruction error in scikit-learn's dict_learning . This means the dictionary learned doesn't represent the data well. It's like trying to build with the wrong set of blocks. You can't make the desired structure. Let's fix it. Max iter controls how many times the algorithm tries to improve the dictionary. More iterations mean more chances to find a better fit, just like trying different arrangements of building blocks until you find the perfect one. Let's give it more time to work its magic. Alpha controls how simple the representation is. A smaller alpha allows for a more complex, denser representation, more building blocks and more flexibility. This might help capture more detail and lower the error. Think of it like having more building blocks to work with. Increasing alpha makes the representation simpler, using fewer building blocks. While this can be good for some problems, it might lead to information loss and a higher error if it's too simple. Too simple is not always good. Different solvers are like different tools. One might be better suited for the job than another. Switching could lead to better results, just like using a hammer instead of a screwdriver when appropriate. Let's try a different approach. This refers to the error in reconstructing the original data using the dictionary learned by scikit-learn's dict_learning function. A lower error means a better representation. I'm asking which changes to the dict_learning parameters could reduce the error. This is the heart of the quiz. We're troubleshooting a machine learning model.